Hello, it's Mrs. Metzler. Remember me? Guess what? These are your last examples slash notes for the year. So here we go. Either you've written down the examples or you've printed the page from the Focus web page. You also have in front of you your unit circle. I just want to do a couple more different examples with you. Make sure we're on track. We will have our last test next weekish sometime. All right, so here we go. Where's my tools? Draw. Got it. All right, so the first one, I see I have two terms. This is a term, and this is a term. A lot of these trig equations involve factoring, so I hope you've been practicing factoring in your spare time. Ha ha ha, just kidding. Here we go. What do you see in both of those terms? Cosecant theta. Take it out. That is your greatest common factor. So take out my cosecant theta. In this term, I'm just left with 2 cosine theta. In this term, I'm left with minus square root of 3. Still equal to 0. That's a bad theta, sorry. All right. Now I got two terms being multiplied. I can just set each of them equal to 0. So cosecant theta equals 0. And 2 cosine theta minus square root of 3 equals 0. Cosecant theta is already solved, so we just got to solve this one. I get cosine theta equals, add that to the other side, square root of 3, divide by the 2. And so now remember, here's the part where I'm using my unit circle to see where those values hold true. So here's some of the thinking. What is cosecant like? What is it? What is the reciprocal of? It's the reciprocal of sine. So cosecant would be the value 1 over y. So now just let's think about this for a second. Is there ever going to be a situation where I could put a number in for that y and get 0? You're thinking 0. I know it. 1 over 0 is not 0. 1 over 0 is undefined. So for this one, for this part of it, there is no solution. Okay? No solution for this one. All right, let's come over here. Let's look at our unit circle. Where does cosine theta equal square root of 3 over 2? Remember, cosine is your x coordinate. So I'm just going to start at 30 degrees. Boom. I see cosine there is square root of 3 over 2. However, it says in the directions, look right here, it says in the directions to give it 0 to 2 pi. I know we haven't done any differently. I did have a couple other practice or worksheets and stuff, but we don't need to do all that. Being it says 0 to 2 pi, you must give your answer in radians. So at 30 degrees, where it equals square root of 3 over 2, theta would equal pi over 6. Let's keep going around the unit circle. All I'm looking at is the x values. So I'm in quadrant 2 now. All those x values are negative. I don't want negative square root of 3 over 2. I'm in quadrant 3. All those x values are negative. I'm in quadrant 4. Boom. 330 degrees. 11 pi over 6 is also the value square root of 3 over 2. Okay? And that's it. You have to write the no solution part. You have to write these values. So again, it's nothing new than last week. Just, like I said, I just wanted to try some more examples. All right, the next one. Again, a little different. Reason I picked it. I know you guys don't like fractions. Fractions are your friend. Yeah, sure. How can we get rid of that sine theta in this middle term right here? What can you multiply that fraction by to get rid of that sine theta? You multiply it by sine theta, and that will cancel it. And that's a fair move as long as you multiply every term in your equation by sine theta. Okay, so that's what we're going to do. So sine theta times sine theta gives me sine squared theta. 4 over sine theta times sine theta just gives me, so really it gives me this. I'm going to show it to you because I know fractions are challenging. It really gives me this, right? But then what happens to both those sine thetas? Goners. and then plus 5 times sine theta, just 5 sine theta, still equal to 0. All right, think of your form when we're factoring. Remember, this is something like standard form. All right, so this is the same thing, except ours is in the form sine squared theta plus sine theta plus something. So I'm just going to rearrange it. Sine squared theta plus 5 sine theta, that's a bad 5, sorry, plus 4 equals 0. Okay, so now it's just a factoring problem. Use your guess and check method, whatever you want. Sine squared, what gives me sine squared? Just sine theta times sine theta. And what gives me 4? What, 1 and 4, 2 and 2? What will add to 5? 2 plus 2 is not 5. 4 plus 1 is 5. Good job. Okay. All right, set each of those equal to 0. I get something like sine theta equals -4 and sine theta equals -1. Well, I hope you know by now, is there a -4 anywhere on that unit circle? Nope. No solution for this guy. And then let's talk about -1. Sine is which value, x or y? Y. So now just look on your unit circle. Where is the y value, -1? Again, I'm starting at 0, 30 degrees, going around. I see at 90, it's +1. At 180, it's 0. Boom, 270. It is, the y value is -1. So theta equals, remember we can't write 270. We're writing 3 pi over 2 because the direction said between 0 and 2 pi. All right, let's continue on, see if there's any more. We're looking at the y value. Nope, I'm back to 0 and 2 pi and we're at 0. So that's the only solution for that part. And that's, don't make any rules in your head. Oh, one is always going to be no solution. No, that's not true. Don't make any of those rules in your head. Just test each one. All right, last one. I think on the last example had this, but I know I had to kind of rush because I was having serious internet problems. That won't happen today. I'm back to the world of real internet. So the first step we did last time is you notice that you have a cotangent and a cosecant. You can't have two different trig functions in the same equation. So you have to find a way to either make cotangent squared something cosecant, or find a way to make cosecant something cotangent. Okay? So I'm turning back over to my other side of my unit circle with the trig identities, where we use the reciprocal identities and the Pythagorean identities. I don't see anywhere where it says anything about cosecant becoming cotangent, but if you look under your Pythagorean identities, the third column, the first one says 1 plus cotangent squared equals cosecant. Well, that's not exactly what I have, but look at the manipulated one right under it. Cotangent squared, A, theirs is, of course, equals cosecant squared A minus 1. I think that's the one I'm going to use. So I'm going to substitute for cotangent squared. 3 times cosecant squared theta minus 1. Remember the theta and the A, same thing, just represents your angle. If you don't like A, use theta. If you don't like theta, use A. Use X, doesn't matter, but put an angle there. All right, so that's all I did was make that substitution using my Pythagorean identity. Okay, now let's just clean up the equation. We're going to distribute that 3. So 3 cosecant squared theta minus 3 plus cosecant theta. Remember, you always want your equation equal to 0. So I got to bring this one over. So plus 1. Okay, now I can combine some stuff. This guy and this guy. -3 plus 1. Good job. So what, minus 2? After I made fun of it, I couldn't figure it out. Okay. All right, again, it looks like that factoring form. Just look at it like this. Right? Plus something. That's your factoring form. So boom. You guys mostly learned guess and check. So I know the only way to get 3 is 3 times 1. So this has to be 3 cosecant theta and cosecant theta. And then negative 2. So what, it has to be 2 and 1 some combination, right? But then I want my middle guy to be a 1. So I know it's going to be a 1 and a 2. Let's see. I want it to be a positive 1, I think. Let's see if I put a positive 1 here and a negative 2 here. What do I get? I get 3. Then here I would get 3 cosecant. Oh, that's a minus. Here I would get minus cosecant. So 3 minus 2 is 1. That works. And I get the final term. All right, that worked. I got lucky. I really did not work this one out ahead of time. Whoops. I was in a rush. All right, so set now each of them equal to 0. Cosecant theta plus 1 equals 0. So here we get what? Cosecant theta equals 2/3. And cosecant theta equals negative 1. So 2/3. Looking at the unit circle. Do you see 2/3 anywhere there as any of the x or y coordinates? Nope, that's a negative. So no solution for this guy. Cosecant. So cosecant is like sine. So that means cosecant is 1 over y. So I'm looking for where the y value, what y value could I put in here to get negative 1? Well, it would have to be negative 1, right? It's the only way I could get to that. So I'm looking for where is my y value of negative 1. So again, I'm just starting at 0, going around. I think we just did one like this, but I already forget. I'm getting old. So boom, boom, boom. I'm down to, oh, look at 270, negative 1. So theta would have to be square root of 3 over 2. And I don't think there's any more negative 1s. So that would be it. All right. So I know I went a little fast. Sorry. Last time I ran out of time and I had to redo the whole video 3 times. So if I talk too fast, you can pause me. So I guess that's it. No more notes. No more videos. I hope to see some of you next year, either in the hallway, hopefully not in class again. And so I guess I need to give you another letter. I was supposed to give you a second letter for the last test, but I forgot. It's okay. So what our special letter this time will be, we'll do it backwards. Our special letter this time will be E. Since our last one was G. I didn't want to do EG, that was too easy. So this time our special letter will be E. Now I just need to make a note to myself to make sure I include that question on the test. All right. Let me know if you have any questions. Text me, call me, email me. Take care. If you're listening to this on Friday, wear your seatbelts, wash your hands. Bye.